Hey all, this is Alan with Bothell STEM Coach, and today we are doing another AP Calculus difficult integral problem. All right. So again, as I caveated, these integrals are definitely harder than what you would see on the AP exam, but it gives you an insight as to like what a challenging problem might be, and just a good exercise that if you're able to use the different techniques of integration. Now, one thing I want to note for this integral is the integral of 1 over 1 plus e to the x dx. And I do want you guys to try it. But I'm going to give you a note. For those who are in AP Calculus, maybe AB, when you haven't learned partial fraction decomposition, if you come across a form like this, know that you can write it like this instead. And that may or may not, well, that will definitely, I'm giving you this hint, make your integral easier to do. Okay, so give it a shot and then come back after you've tried the problem. Okay, so it's not obvious. I mean, this hint was a little bit tricky because it's not obvious, like, can I factor something out or anything like that? Actually, what you have to do is you have to do a little bit of algebraic manipulation first. So I want to take this e to the x, and I'm going to multiply by, like, a good initial guess, what a lot of people might come to in the beginning is to do this, 1 minus e to the x, or e to the x minus 1, doesn't really matter. And they might attempt to do this. And then this is difference of squares, so this becomes 1 minus e to the 2x, and that's because e to the x squared is e to the 2x. Okay? But there's no clear u substitution is going to help you at this point, necessarily. So, like, this is actually, well, I mean, there might be a way that you could rearrange things, but this is sort of not a very clean way to do the problem, in my opinion. So what I would say is the easier way to do the problem. The problem is this one part that's kind of annoying a little bit, because I need to get an e to the x so I can kind of do u substitution. That's what I'm kind of thinking at this point. So you got to do 1 plus e to the x. So what if you just did e to the x over e to the x without a minus 1 or whatever? Then I'd have e to the x over e to the x plus e to the 2x. Or this is e to the x squared. And here what happens is if I do u substitution for e to the x, and du is e to the x dx, then when I integrate e to the x over e to the x plus e to the 2x dx becomes the integral. My e to the x dx is my du. E to the x is u. And this e to the 2x is u squared, right? Because u squared would be e to the x quantity squared, and one of the rules for exponents is I just make that e to the 2x, right? That's basically what happened here. Okay, I can write this as du. I can factor out a u plus 1. And those of you who have gone a little further in calculus or BC, you can do partial fraction decomposition. I gave it to you when you have something like this. This becomes the integral of du over u minus the integral of du over u plus 1. Okay, because I can write this 1 over u times u plus 1 as 1 over u minus 1 over u plus 1. And each of these integrals is natural log absolute value of u minus natural log absolute value of u plus 1 plus c. With natural logs, I can combine subtracting by absolute value u over u plus 1 plus c. And the last step is I got to replace u with e to the x. Actually, maybe I should have done that first. And then you can kind of see this has become natural log. E to the x is always positive, so I can get rid of the absolute values. So it's e to the x minus natural log of e to the x plus 1 plus c. This is x minus ln e to the x plus 1 plus c. And that is as simple as you could probably make it. Okay? So I hope you found that instructive and helpful. Like I said, these are more difficult than what you would see on the AP exam. But yeah, I will see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.